your entire data is concentrated. Okay, there are more values in the data which are somewhere close to this central value or middle value. So we call this as a measure of central tendency or measure of location. Okay. So in this we'll be studying today the different types of measures of central tendency, mainly the mean, median, mode, and few others also. Okay. I hope everything was clear now, what all we have done in the last two lectures.
Yes, sir.
Yes, sir.
Okay, okay,
Yes, sir.
okay. Thanks. I'll wait another couple of minutes. I've shared one file. Well, if you're able to see that file.
Yes, sir.
Okay.
Sir,
Okay. Yeah.
sir, you're going to upload the files in the
Uh,
team section.
yeah. Okay. I'll upload that also. I've also mailed. You must have received in your mail also, no?
Yes, sir. Received in the personal mail as well, sir.
Yes,
Uh,
yes,
so if you want, I'll upload it on the Teams also. Okay. I'll do that. I'll do
yes.
that. Yeah.
Okay.
Plus, I've sent you all the recordings also, so that
Yes, sir.
anything if you
Yes,
miss
sir.
out sometime, you can always go through that again.
Okay, sir.
Plus, the recordings will be useful, like in case if you miss out some lecture or whenever the other remaining batch of our students joining. Okay, like we still have the strength. So when the other half joins in, then even they can go through what all was covered. So they'll also not miss out much. Okay. So that time these recordings will be really useful. And plus you all are there to help each other. So should not be a problem. Okay. So, okay. So these are the things we have seen in the last couple of lectures. Okay. So, so now, okay, gradually, okay, I'll just start. How many are there still? Many more people are still to join, no? Okay. So you had all the other lectures today, all the two lectures before this. No, it's three lectures before this, no?
Yes, sir. We had three lectures before this.
Okay. Because it takes some time getting used to like online lectures every day. So
Yes, sir.
and plus getting used to Teams and this one. So but it was a new platform when it started for everyone. So
Yes, sir. Please.
yeah. Maybe it may take another maybe 1 or 2 months, or maybe even more. I don't know when physical classes could start. Till now, it's not known anything when they would start. Okay. Okay, I'll just gradually start. So in this file, as I've told you, we just started with what do we mean by measures of central tendency or measures of location. So in that, the most simple one is the arithmetic mean or the average, the simple average which we have, which we use every day for something or the other. Okay, so as we know the average, we just get it by adding up all the values divided by number of values. Okay, like say if I have in our class of 50 people, okay, I want to find out the average marks. So we'll have to just add up the marks of everyone and divide by 50. That will give us the average, arithmetic mean, or simply the mean also we can call. Okay, so that is one thing we have got here. So as you can see on the screen here, if x is some variable which has these values like x1, x2, x3 and so on till xn, say there are n values. Okay, so we can denote the average of this variable as x bar. Okay, that is a notation we can use for the average of the variable x bar. Okay, and we can write it as summation x upon n. Okay, sigma x, summation x means adding up all the values of x divided by n, number of values. Okay, so that is the first basic formula we can use for finding out the average. Okay, adding up the values divided by number of values. So if I have say 5 values, we'll just have to add up all 5 of them and divide by 5. Okay, so that is how we'll get the average. So that's the first thing we have seen. Okay, so all of you can note down this formula, the first basic formula we can have for the average. Okay. Okay, so that's the first one. Now, in this could like we could happen that the values could repeat also. Okay, that means frequencies can be given. Okay, like say there are 5 students who have got 70 marks, or 10 students who have got 60 marks, etc. That means each value of the marks can repeat also. So in case if there are repeating values, then in that case we can find out the average like this. So as you can see on the screen here, x is some variable like say marks, f is the frequency. That means how many times the value is coming. Okay, so this means that the value 2 is coming 3 times, 4 is coming 2 times, and 6 is coming 5 times. Okay, that's the meaning of this one. Frequencies are given. Okay, and we want to find out the average for this. Okay, so all of you can note down this example. You can just note down the first 2 columns, x values and frequencies. Okay, then we'll see how to get the average here. Okay, everyone clear na till here?
Yes,
Yes,
sir.
sir.
Yes, sir.
Yes,
Okay,
sir.
okay.
Yes, sir.
Yeah, okay, thanks. So x values and frequencies are given here. Okay. Now in the earlier example we saw now that we just used to add up all the values divided by number of values. Now here the value 2 is coming 3 times. So I'll have to take 2 3 times. That means 2 plus 2 plus 2. Okay, which is same as multiplying 2 by 3. Okay, so that's why we have kept this column here, f into x. Okay, because rather instead of adding 2 3 times, it is same as multiplying 2 by 3. So that's why the reason for this column, f into x. So 2 3s are 6, 4 2s are 8, and 6 5s are 30. Okay, that is our this column, f into x column. And then we take the total of this column here. Okay, so that comes out to be 44. Okay, 6 plus 8 plus 30. Okay, so that is nothing but the sum of all the values, sigma fx. Total of all the values is this much, 44. And then I need to divide it by the number of values. Now here, the number of values are not 3 here. The number of values are the sum of the frequencies. Because 2 is coming 3 times, 4 2 times, and 6 5 times. So the actual number of values are 3 plus 2 plus 5. That is 10 values. Okay. So that's why, as you can see in the formula here, we write like this. X bar is summation of fx divided by sigma f. Okay, sigma fx means total of the fx column, and I'm dividing by sum of the frequencies. Okay, sigma f. Sigma f is nothing but n, the number of values. Okay, so here we get it as 44 by 10, that is 4.4. Okay, so whenever frequencies are given like this, okay, this is the procedure we follow, that we multiply the x values with the frequencies first. Okay, and then we take the total of all these products and divide it by the sum of the frequencies. Okay, sigma fx by sigma f, and we are getting the answer as 4.4 here. Okay, so this is how we find out the average or the arithmetic mean in the case of repeating values. Okay, everyone's fine till here?
Yes, sir.
Yes, sir.
Okay,
Yes, sir.
okay,
Yes,
okay,
sir.
okay, very
Yes,
good. Yeah, fine. So earlier we saw in the first example which we saw, there were just 5 values which were not repeating. So we just took the total divided by 5. But in this case of repeating values, we have done it this way. And both of them are ungrouped data. Okay. Now we'll see that if I have a group data, that is if there are class intervals, then in a very similar way, we can find out the average. Okay. So if you take this example here, where class intervals are given, and frequencies are given. Okay, so this means that there are 5 values which are present between 0 and 10. Say there are 5 students who have marks between 0 to 10, 2 students who have marks between 10 and 20, and 3 students who have marks between 20 and 30. Okay, that's the meaning of this data here. So we are directly given a group data, class intervals, and we want to find out the average for this. Okay, so all of you can note down the first 2 columns here, class intervals and frequencies. Okay, then we'll use this to find out the average. Okay, so here since we are given a group data now here in this, and we are not having the actual values, okay, like we had in the previous example. So here we'll be finding out the midpoint of each class, the class mark which we saw last time. So that midpoint or class mark will act as a representative of that class. So that I have shown it as M here. Okay, M stands for the midpoint of the class. Okay, and then just like in the previous example where we had done f into x. Okay, so here we'll be multiplying the frequencies with the midpoints. Okay, just like similar to x. Okay, x was the values in the previous one, but here since we don't have actual values, we are taking the midpoints. Okay, so so we have in this case we are multiplying these frequencies with the midpoints. Okay, so f into m. Okay, and then that total we'll take here. Okay, so all of you can just complete these 4 columns here, f into m, and take the total. Okay, just like we had f into x earlier, here we have f into m, and then we take the total of that, and then that total we'll divide by sum of the frequencies. Okay, sigma fm by sigma f. Okay, so sigma fm by sigma f will give us the average value here, which comes out to be 13 in this case. Okay, is this clear, everyone?
Yes, sir.
Yes, sir.
Okay, so okay. So in place of actual values, we have just the midpoints of the classes, multiplied these midpoints with the frequencies, and then that total we are dividing by sigma f. Sigma f is nothing but n, the number of values, which is 10 here. Okay, so this is how we get the average or the arithmetic mean in the case of group data, where we have class intervals. Okay, has everyone completed till here?
Yes, sir.
Okay.
Yes, sir.
Yes, sir.
Okay, fine. So as we have seen here, the average is very simple to get. Okay, whether it's ungrouped data as we saw earlier, or whether it is group data in this case, it's very simple to find, and it's given by a very well-defined formula. That's the main advantage of the mean. Okay, very well defined, and it does not depend on the order of the values. Okay, whichever order of the values you take, the average will remain the same. Okay, like say if I have to find out the average marks for our class, whether I take roll number 3 first or roll number 45 first, okay, it will not affect the average. Okay, and also one more thing is that the average is based on each and every value of the data. So if some values are missing in the data, we'll not be able to find the correct average. Okay, like say in our class of 50 right now, suppose if I don't know the marks of 5 people, so I have only the data of 45, so I can't find out the exact average of the whole class, because I need the marks of everyone to find out the correct average of the entire batch. Okay, so the average is based on each and every value. Okay, that is one more property of the mean or the average. Okay, and one more feature of the average is that we can always combine the averages of 2 or more data to get the combined average. Okay, like say if I have 2 batches or 3 or 4 or even more, we can always find out the combined average marks of all these batches together. Okay, and this thing is not possible in the other measures like median or mode because they are not so well defined like the mean. Okay, so that's another advantage of the mean. Okay, the arithmetic mean. Okay, like if I just take an example here, suppose we consider uh, say 2 batches are there, you may have even more, 3, 4, 5, any number of data you can have. Okay, suppose I take 2 batches and say the first batch has say 60 students. Okay, and say their average marks are 75. Okay, like say suppose our batch has 60 students, say presently suppose. Okay, and say our average marks is 75, and say there's another batch of 30 students, a small batch, and say their average marks are 65. Okay, so so we have we want to find out the combined average of both the batches together. Okay, so for this what we do is we can express it in this way. Okay, n1 is 60. This particular file also I have mailed you all yesterday. Okay, so right now you can just understand this. Okay, n1 means number of students, the strength of the batch of say our class is 60 suppose, and say our average marks are 75 x1 bar, and say the other batch n2 strength is 30, and say their average marks are x2 bar, say 65. Okay, so these things are given to us. Okay, now based on this I want to find out the combined average. So what we do is, now for getting the combined average I need to know the total marks of students of both the data, both the batches. So as we saw earlier, the formula for the average was x bar is summation x by n. Okay, this was the formula we saw, where summation x stands for the sum of the values. So in this formula, we can calculate summation x as n into x bar. Okay, if I just cross multiply, we can say sigma x is equal to n into x bar. That means the sum of the values will be nothing but number of students into the average. Okay, so by using this formula, I can find out what is the sum of the marks of students of both the batches. So if I multiply n1 with x1 bar, it will give me the total marks of students for our batch. Similarly, if I multiply n2 with x2 bar, it will give me the total marks of students of the other batch. Okay, and then when I take them together, if I add them both this way, n1 x1 bar plus n2 x2 bar, it will give me the total marks of students of both the batches taken together. Okay, it will be the sum of all the values of both the batches together. Okay, so this particular thing we'll take in the numerator. Okay, total marks for our batch plus total marks for the other batch. Okay, this entire thing is in the numerator divided by the total number of students, and total number of students are n1 plus n2, the total strength, that is 60 plus 30. Okay, so using this formula, okay, we can find out the combined average of both the batches together. Okay, this is how we arrive at this formula. Okay, so it's I mean not something very difficult to derive, it's very easy, just adding up the sum of marks of both the batches and then divided by the total strength n1 plus n2. Okay, so all of you can just note down this formula, which you can extend it even to more than 2 batches also. Okay, like suppose you have got 3 batches, then it will be n1 into x1 bar plus n2 into x2 bar plus n3 into x3 bar whole divided by n1 plus n2 plus n3. Okay, so this can be extended to any number of data like this, and then we have to just put the values in this formula and we'll be able to get the answer here. So all of you can just try, see, are you getting this answer here for the combined mean? Okay, all of you can note down the formula first for the combined mean. and then when we substitute the values, we'll be able to get the answer here. Okay, everyone getting this here? Okay, can you see, are you getting this answer here? 71.67.
Yes, sir.
Yes, sir.
Okay, fine. So this will be the combined average marks of both the batches taken together. And same way you can do it for any number of data. Okay, everyone is clear till here?
Yes, sir.
Yes, sir.
Okay, very good. Okay, so that is one property of the mean, that we can always find out, we can always combine averages of two or more data to get the combined average. Okay, that's one important feature of the average. Okay, so we have seen a lot of features like that. It's very well defined. We can combine averages. It is based on each and every value, and it does not depend on the order of the values. Okay, these are some important properties of the arithmetic mean. Okay, and it has got one limitation, that if there are extreme values present in the data, then the mean does not act as a good representative of the data. Okay, like say if I take an example, suppose I consider values like 0, 10, 50 and 1000. Okay, I'm taking these values here. Now in this data, if you see, there are very small values like 0, and there is a very high value like 1000. So there are extreme fluctuations, extreme values are there in this data. Okay, now if I find out the average, okay, our basic formula is sum of all the values divided by number of values. So if I find out the total here, it comes out to be 1060, and divided by number of values 4, and on solving this we get it as 265. Okay, so adding up the values divided by number of values. Okay, now once we get this average value of 265, now by looking at this value, we may feel that the values in the data are somewhere close to 265. Okay, but then if you see the actual data, there is no value which is close to 265. Okay, because some values are quite small like 0 and 10, and one value as high as 1000. Okay, there is no value anywhere close to 265. Okay, so this value of 265 is not able to represent this data properly. Okay, so that's the limitation here, that in case of extreme values present, the mean does not act as a good representative of that. Okay, it does not help us to get a proper picture of the data. Okay, like say if I have a data on income of people for the entire country, suppose. Okay, and you want to find out the per capita income. So this per capita income, like say suppose I say that so the per capita income is suppose it's around, I think, $3,000, suppose some value. Okay, now this does not give us a proper picture of the actual financial condition of the people, because there are many people whose incomes are very low, okay, below the poverty line, and there are many who could be very rich, say billionaires. So this per capita income does not give us a proper value of that. Okay, because of extreme fluctuations in the data here. Okay, so in such a case where you have a data with huge fluctuations, then possibly the other measures like median would be better here to represent the data. Okay, so that is one limitation of the mean, that when there are extreme values, the mean will not be able to act as a good representative of this data. Okay, is this clear, everyone?
Yes, sir.
Yes, sir.
Okay, fine. Okay, so it has more advantages, and this is the major limitation it has, that in case of extreme values does not give us a proper representation. Okay, now we have seen the mean or the arithmetic mean, the simple average. Okay, just another variation of this is called as the weighted average or the weighted mean. So it is very similar to the normal average, The only thing is that different values are given a different weightage or a different importance. Okay, means each value is not getting the same importance but a different significance. So on that basis we are able to find out this weighted mean or weighted average. Okay, we'll take an example, from that it will be clear. Okay, like say for our evaluation we have number of criteria. Okay, like say we may have a test, assignments, presentations, final exam, okay, etc. Okay, so that can vary across subjects. So suppose these are some of the criteria. Okay, and each criteria has got some particular weightage, some importance. Okay, so as you can see on the screen here, I have taken these 4 criteria here: test, assignments, presentations, and the final exam. And the weightages are given. Say a test has 10% weightage, assignments say 20%, presentation say 10%, and final exam 60%. Okay, so these are the weightages W, okay, given to each of the 4 criteria. Okay, and we also have the marks given, say X, of one particular student. Okay, now say this student has got 75 out of 100 in the test. Okay, here I am taking that each parameter is out of 100 marks just to have a common base. Okay, so I'm assuming that the test is out of 100 marks, assignments also out of 100, presentations out of 100, and final exam also out of 100 marks. Okay, so this particular student has got 75 marks out of 100 in the test, 70 for assignments, 68 in presentations, and 60 in the final exam. Okay, so we are given the marks of this particular student X, and we are also being given the weightages W. Okay, so now these weightages are very similar to frequencies. Okay, like when we say that some particular value has a high frequency, that means it is repeating more often in the data. And when something repeats more often, that means it automatically gets a higher importance or a higher weightage in that data. So frequencies are similar to weightages. Okay, so as in the earlier example that we saw, when we saw this example first, one second. Yeah, in this example, what we did was X values was given and frequencies were given, and we had multiplied frequencies into the X values, F into X. And then we had got the total of that and divided by sigma F. So exactly the same thing we'll be doing here in the case of weightages also, because as I told you that weightages are very similar to frequencies. So here also we'll just multiply the weightages with the marks, so W into X. Just like we had F into X, same way we have W into X. Okay, so each weightage will be multiplied with the marks of the student. Okay, and then we'll take the total of that. Okay, okay, what you can do is, okay, all of you can note down this one, this table you can make here, 4 columns here. Okay, and then we can see the final answer. Okay, so weightages are given in terms of percentages here, and you can see that the sum of all the weightages is 100%. Okay, it will all add up to 100%, and marks are given in each criteria for this particular student, and then we just multiply the weightage with the marks, W into X. So 10% of 75 is 7.5, 20% of 70 is 0.2 into 17, so that's why it becomes 14. 10% of 68 is 6.8, and 60% of 60 is 0.6 into 60 becomes 36. Okay, so this is how we get the values of the last column, W into X. and then we'll take the total of all these products. Okay, so all of you can just see how much is the total of this last column coming here.
64.3.
4.3, right, very good. Yeah, so the total of the last column is coming as 64.3. That means the WX total is coming as 64.3. Okay, has everyone completed till here?
Yes, sir.
Yes, sir.
Okay, very good. So we got this total as 64.3. Okay, so we just use this formula that sigma Wx upon sigma W. It is very similar to sigma Fx upon sigma F. Okay, exactly the same thing. Just in place of frequencies, we have taken weightages. That's all. Everything else remains the same. So summation of Wx by sigma W. So 64.3 is the numerator upon 1. Why 1? Because the weightages are all adding up to 100%. Okay, all weightages are adding up to 100%. 100% is 100 by 100. That is 1. So that's why I have taken the denominator as 1 here. So 64.3 divided by 1. So we get the answer as 64.3. So this is the overall marks which this student has got. Weighted average marks. Okay. That means taking into account all the 4 criteria, this particular student has got 64.3 out of 100. Okay. Now this student has done well in the test and assignments and presentations, but in the final exam, the performance went down. But actually final exam had the maximum weightage. So if he or she had done better in the final exam, the marks would have been better. Okay, so where the weightage was the maximum, the performance has gone down. So that led to a drop in the overall performance also, and it became just 64.3. Otherwise, he or she would have got over more than 70%. Okay, so that shows the importance of the weightage. Okay, so in weighted average, each of the values is given a different weightage or a different significance. Okay, otherwise it's very similar to a normal average. Okay, and this can be used in a number of applications. Like say if you want to find out weighted average cost of capital. Okay, that is one example. Like capital is the money that you require for running your business, which you can get it from various sources like equity or loans or debentures or retained earnings or the promoter's own contribution, etc. So these are the various sources of finance, and each source will have its own cost. Okay, so this cost you can take it as X. Just like in this example, we had marks was X. Same way, the cost of that source of finance will be X, and how much is that source of finance in the total will be your weightage. Like suppose 10% of your money you get through equity. So 10% is the weightage, or 20% you get through loans, or 25% you get through debentures, or say 50% is your own contribution. So these are all your weightages W, and the cost of the source of finance will be your X, and then multiplying that W into X, we can find out total of that sigma Wx by sigma W will help us to get the weighted average cost of capital. Okay, so that is one area where this can be used, or similarly we can use it for performance appraisal also. Okay, like say you have joined the corporates, and for appraisal they are saying that you have criteria like technical skills, leadership skills, or interpersonal skills. Okay, so a lot of parameters they have kept. So depending on what score you get in each of them, that score will be your X, and each of these parameters will have some weightage W. So again, based on that, we can find out the weighted average score for each employee, which can then be used for promotions and other things. Okay, so these are some areas where weighted averages can be used. Okay, so these are the first two measures of central tendency we have seen. First was the simple average, which is called as the arithmetic mean, and the second one is the weighted average, which is the weighted mean we have seen now. Okay, is this clear, everyone, till here?
Yes, sir. Yes, sir.
Okay.
Yes, sir.
Okay, good. Now we'll see the next important measure, which is the median, which we saw yesterday also, that this represents the middle value of our data. Okay, and remember we got it from by using the two CF curves. The intersection of that will help us to find out the median graphically. So median basically divides our data into two equal parts. So you can say that half the data is on both sides of the median. Okay, like say if I say that the median marks for our batch is 60. Okay, so it will mean that half the class has got marks less than 60 and the remaining half will have more than 60. Okay, that is the meaning of this one. But there is a difference here that the median is a positional measure. That means it is based on the position or the order of the values, unlike the average. Okay, the average was not based on the order, but the mean is based on the order of the values. So here we'll have to first arrange the values in some order, like ascending order or descending order, and then we'll have to see which is the middle term. Okay, so that is one main difference here between the mean and the median. The median is based on the order of the values. So the first thing we'll be doing for any data would be to arrange the values in ascending order or descending order, and then we'll be able to locate the middle term. Okay, so that is one important thing regarding the median, that is it's a positional value. Okay, now how many middle terms are there will depend on whether we have an odd number of values or even number of values. Okay, like say suppose I have got 3 students, then the second one is the middle student. So there is only one middle term. Okay, when there are 3 terms, 3 is an odd number. So whenever you have an odd number of terms, there will be just one middle term. Okay, like say suppose I have got 5 values, the third one is the middle value. Okay, but suppose if I have got 4 students, then there are 2 middle students, the second and the third one. Okay, so whenever the number of terms will be an even number, we'll have 2 middle terms. Okay, so that is one important thing we have to just keep in mind about the middle terms. So if the number of terms we can denote as n is an odd number, then we'll have just one middle term. Okay, and the median will be given by n plus 1 by 2 term. Okay, n plus 1 by 2, that is the median here. Okay, like suppose n is 5, odd number. So 5 plus 1 by 2 will be 6 by 2, that is the third term. Okay, so first we'll have to arrange the terms in say ascending or descending order. Then we'll have to see which is the third term, that will be our median then. Okay, so in the case of odd number of terms, there is just one middle term and that is given by n plus 1 upon 2 term. Okay, like suppose you have 7 terms, then it will be 7 plus 1 upon 2, 8 by 2, that is the fourth term. Okay, is this clear everyone?
Yes, sir.
Yes, sir.
Okay, okay. So for odd number of terms, you can just remember, you can just keep in mind that the median will be given by n plus 1 upon 2 term. Okay, later we'll see the example also. And if the number of terms is an even number, then as I said, we'll have 2 middle terms. And these middle terms are given by n by 2 and n by 2 plus 1 term. Okay, there are 2 middle terms. First one is n by 2 and the second one is n by 2 plus 1, means the next one. Okay, like suppose there are say 6 terms. Okay, so n is 6, even number. So when it's an even number, like what will be n6 here, n by 2 will be 6 by 2, that is the third term, and n by 2 plus 1 means the next one, fourth term. So third and the fourth term will be our middle terms. Okay, and then we'll have to just take the average of these two middle terms to find out the median. Okay, so whenever n is an even number, number of terms is an even number. Okay, we'll have two middle terms, which is given by n by 2 and the other is n by 2 plus 1. Okay, like suppose there are 10 terms, n by 2 will be 10 by 2, that is fifth term, and the next one is the sixth term, fifth and sixth. These will be the middle terms. And but the first step will always be to arrange the terms. Then we'll have to see which is my fifth term and sixth term, and then take the average of these two middle terms. That will give us the median here. Okay, is this clear, everyone?
Yes, sir.
Yes, sir. Yes, sir.
Okay.
Yes, sir.
So yeah, fine. So 1 second, I'll just take an example of this. 1 second. Yeah. So I'll just take an example how we can find out the median in this case when we have either odd number of terms or even number. Okay, like suppose if you take this one. Okay, if you see this example here, 12, 6, 25, 8, and 19. Okay, I have this data. So the first step would be to arrange these values. You can arrange them anyway, either in ascending order or a descending order. Okay. Okay. So that will be the first step, arranging the values. And then we'll have to see what is n here. Now, since there are 5 terms here, n is 5, okay, which is an odd number. So I'll just show you how we do this. First step is we have just arranged the terms in suppose ascending order. So we get like this. Okay, 6, 8, 12, 19, and 25. We have arranged the terms in ascending order. Okay. After arranging the terms, then we'll have to see what is n. So n is 5 here, which is an odd number, and so we'll have just one middle term, which is n plus 1 by 2. So 5 plus 1 upon 2 will be 6 by 2. That is the third term. So then we'll have to see which is the third term here. So in this data, the third term is 12. Okay, this one is my middle term, 12. And so the median will be 12. Okay. Is this clear, everyone?
Yes,
Yes,
sir.
sir.
Yes,
Yes,
sir.
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 Okay.
Yes,
Okay.
sir.
Yeah, good. So we have seen that it's very simple how we get the median here. Okay, just arranging the values first. Then we saw that n was odd 5, and so there's just one middle term, which is the third term, and so our median is 12 here. Okay, so very simple here. Now similarly, if I take this data here, okay, and for this data, okay, you can note it down. Again, I want to find out the median for this. Okay, so this is the data we have been given here, and the first step will be to arrange the values. So we arrange the terms in ascending order as shown here. Okay, so always you have to remember this step here, arranging the terms. Okay, only after arranging the terms, we'll see in this case whether it's an odd or even number, and then find out the median. Okay, so we have arranged the terms in ascending order here, and then we see that there are total 6 terms here. So n is 6, which is an even number. So since it's an even number, we have two middle terms here, that is n by 2 and n by 2 plus 1. So 6 by 2 is third term, and the next one is a fourth term, third and the fourth. Okay, so we have to locate which is our third term and the fourth term in the arranged data. Okay, not the earlier one. In this arranged data, we have to see which is the third term and the fourth term. So third and the fourth terms are 18 and 28. Okay, these are our two middle terms here, and so our median will be average of these two middle terms. Okay, so we'll take the average of 18 and 28, and from that we'll be able to get the median here. Okay, so all of you can note down this one. So middle terms are 18 and 28, and so their average comes out to be 23. So the median is 23 here. Okay, is this clear, everyone?
Yes, sir.
Okay, okay, very
Yes,
good.
sir.
Okay, yeah, fine, fine. Okay, so we have seen how to find out the median, like first arranging the values, then seeing whether n is odd or even. If odd, then just one middle term, and if even, then there are two middle terms, and we take the average. Okay. Now, in all these examples, both of these examples, there was no repeating value. But if there are repeating values, that means if there are frequencies given, okay, like suppose if given like this, we have this data here, x values and frequencies are given. So 3 is coming 8 times, 6 is coming 5 times, 4 is coming 4 times, and 5 is coming 2 times. Okay, we want to find the median for this. Okay, all of you can note down this one here. Okay, now in this case for this data, okay, what should be the first step we should do here?
Arrange them.
Yeah, right, right, very good. We'll first arrange the x values in ascending or descending order and write the corresponding frequencies. Okay, so that will be the first step. We'll arrange the x values, say in ascending order. Okay, so as you can see, x was given 3, 6, 4, 5. So when you arrange it in ascending order, it will become 3, 4, 5, 6. Okay, so we'll arrange the x values first in ascending order and write down the corresponding frequency for each of them. So it will become like this: 3, 4, 5, 6, and just write the corresponding frequency. Like for 3 it was 8, for 4 it was 4, like that. Just write down the corresponding frequencies. Okay, so that's the first step. And then we'll also find out the cumulative frequencies here, CF, like how we did yesterday, by just adding up the successive values of the frequencies. Okay, so all of you can note down this. X values we have arranged in ascending order, written the frequencies here, and then we'll find out CF. These are nothing but our less than CF values, which we saw yesterday. So first one is 8, then next becomes 8 plus 4, 12, 12 plus 2, 14, 14 plus 5, 19. Okay. And when you find out the cumulative frequencies, the last CF value will give us the total number of values. Okay, like as you can see, the last CF value is 19. Okay, so this 19 is actually the total number of terms, n. Okay, so the number of terms comes out to be 19 here, which is an odd number. Okay, like just like in the earlier case, here also we'll have to see whether the number of terms is odd or even. So from the last CF column, last CF value, sorry, 19, we are able to get the number of terms as 19. And we know it's an odd number. Okay, has everyone completed till here?
Yes, sir.
Yes, sir.
Okay,
Yes, sir.
okay, 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 very good. So number of terms is an odd number here, 19. So since it's an odd number, we know that we'll have just one middle term, which is n plus 1 by 2. So 19 plus 1 by 2 becomes 20 by 2. That is the 10th term. Okay, so we know that median will be the 10th term. Now I have to find out what will be the 10th term of this data. Okay, so for getting that, we have to just see the CF column. Okay, the third column, CF column. Now the first CF is 8. That means till here 8 terms are over. The next CF is 12. That means 12 terms are over. Now we want to get the 10th term. So the 10th term will lie between the 8th term and the 12th term. Okay. Getting this, everyone?
Yes, sir.
Okay, we want to get the 10th term, and the CF, first CF is 8, next CF is 12. So our 10th term lies between the 8th term and the 12th term. Okay. Now, can anyone tell me what would be the 10th term here? Anyone can just try?
4.
Yeah,
Four.
yeah, yeah.
Four.
Right. Yeah, right. Very good. Okay, I'll explain this also once. I'll explain this. See, the first, as you can see, the value x 3. The first value of x is 3, and 3 is coming 8 times. That means the first 8 values are all 3. Okay. Then the next value is 4, which is coming 4 times. So that means the 9th, 10th, 11th, and 12th terms are all 4. Okay. First 8 terms are 3. The next 4 terms are 4. 9th, 10th, 11th, and 12th terms are 4. Now we want to get the 10th term. And as we saw that it lies between the 8th term and the 12th term. So any term which comes after the 8th term up to the 12th term will be equal to 4, this value of x. Okay, because this value of x which I have shown highlighted here, this is the value of x which is coming after the 8th term up to the 12th term. 9th, 10th, 11th, and 12th is this value x, 4. And that's why we get the 10th term as 4. Okay, and so in this case, the median becomes 4. Okay, is this clear, everyone?
Yes, sir.
Yes,
Okay.
sir.
Yes, sir.
So,
Yes, sir.
so this is how. Okay, very good. So this is how we find out the median in the case of repeating values when there are frequencies given. Okay. Okay. Can anyone just tell me what is the 16th term here in this data?
Six.
5.
Six.
5, sir.
Six.
5.
Uh,
Six.
16th term, 16th term.
Six.
Right.
Six.
Six.
Huh.
Six.
See, 16th term is 6 here. See, it is 6. Why? Because see, till here, at this point which I have shown, 14 terms are over till here. Next is 19. So 16th term lies between 14th term and 19th term. So anything which comes after the 14th term up to the 19th term will be, the value of x will be 6. Okay, starting from 15th, 16th, 17th, 18th, 19th, all these 5 values are 6. So that's why the 16th term will be 6 here. Okay, so you have to just see that this particular term lies between which two CF values. So 16th term lies between 14 and 19. So we have to go after the 14th term. After the 14th term, the next value of x is 6. And so the 16th term also will be 6. Okay, clear, everyone?
Yes, sir.
Okay, fine.
Yes, sir.
What is okay, good. What is the third term here in this data?
3.
Yeah,
3.
right.
3, sir.
Because yeah, very good. Yeah, 3.
3.
Yeah, right. Yeah, because the first CF is 8. So any term up to the 8th term, all of them are 3, because 3 is coming 8 times. So any term from the first term up to the 8th term will be 3. So that's why the third term is 3. Okay. What is the 13th term?
5.
5.
Yeah,
5.
right. Yeah,
Five.
right. Yeah, very good. 13th term is 5 because 13th term lies between the 12th term and the 14th term. So anything after the 12th term, the value of x will be 5. And so 13th term is also 5. Okay. So like this, you can locate any term by looking at the CF column. Okay. So it's very simple. So what we did here was first arranged all the x values in ascending order, wrote the corresponding frequencies. Then we also find out CF values. And from the last CF value 19, we got that the number of terms is 19, n is 19, which is an odd number. So since it is odd, the median is given by n plus 1 by 2. So 19 plus 1 by 2 is the 10th term. So we have to find out what is the 10th term. 10th term lies between the 8th term and the 12th term. So after the 8th term, the next value of x is 4, and so the median is 4 here. Okay, so this is how we found out the median in this case. Okay, okay, I'll just give you another example. Okay, so then it will become more clear how we find out this. Suppose we take like this. Okay, all of you can note down this example here. X values and frequencies are given. Okay, for this data, we want to find out the median. So the first step is the same, that is we'll have to arrange the x values in ascending order and write the corresponding frequencies. Okay, just like we did in the previous case. Same way we'll do here. So the data becomes like this. X values, when you arrange them, it becomes 2, 4, 6, and 9, and write the corresponding frequencies. And then we'll also find out CF, cumulative frequencies.
Six.
Okay. Yeah, right. Yeah, very good. Yeah. So from the CF column, we see that the last CF value is 22. And so we saw that the number of terms is 22 here. Okay. And this is an even number. So when n is even, we'll have two middle terms that we saw earlier, that is n by 2 and n by 2 plus 1. So 22 by 2 is 11th term, and the next one is the 12th term. So I have to find out which are these two terms, 11th term and the 12th term. Okay. So when we see the CF column, first CF is 4, then 7, and the next is 17. Okay, 7 and the next is 17. Now we have to get 11th and 12th term. Now both the 11th and the 12th term will lie between the 7th term and the 17th term. Okay, so any term which comes after the 7th term up to the 17th term, that value of x will be 6. Okay, see till here 7 terms are over and next one is 17. So after the 7th term up to the 17th term, all the values of x are 6. That means your 8, 9, 10th, 11, 12, 13, 14, 15, 16, 17. All these terms are 6. Okay. And we want to get the 11th and 12th term. So both 11th and 12th term in this case are 6. Okay. Is this clear, everyone?
Yes, sir.
Yes, sir.
Yes, sir.
Okay, very good.
Sir.
Okay, yeah. So 11th and 12th term are 6 here. So our median will be average of these two. Average of these two middle terms. So average of 6 and 6 is also 6. So the median is 6 here. Okay. So this is how we find out the median in this case. Okay. So this example, the number of terms was an even number. Okay. So we got two middle terms here. But first step was to arrange the values in ascending order and then write down the corresponding frequencies. Then we got CF values. Okay. And then since last CF is 22, so that means number of terms n is 22 here, even number. So we got two middle terms. Okay, by looking at the CF column, and then we took their average. And in the previous example, n was an odd number, that is 19. So we had just one middle term in that, that is n plus 1 by 2, which was the 10th term, and we had got it as 4. Okay, so this is how we find out the median in the case of repeating values, but still it is an ungrouped data only. Okay, in the previous earlier one, there was the first example which we took was where there was no repeating values, like this example. But in this example where frequencies are given, there are repeating values. Okay, both of these are clear, everyone?
Yes, sir.
Okay,
Yes,
okay,
sir.
fine. Okay.
Yes, sir.
So okay, so what I'll do is, in the next lecture tomorrow, we'll be seeing about how we do median for class interval data. Okay, in class interval data, the difference will be that we don't have to worry about whether n is an odd number or even number.
Okay.
So like whether n is 25 or 26, we'll have to just find out only the n by 2 term. Okay, so and we don't have to see whether it's odd or even, and then by using one formula, we'll be able to get the value of the median. Okay, so okay, we'll see that in the tomorrow's lecture. Okay, hope everything is clear now what you have done today.
Yes, sir.
Yes, sir.
Yes, sir.
Yes.
Okay,
Yes,
okay,
sir.
okay. Has ma'am told anything about the schedule for next week, like like for exams or something?
So she said that we'll be having tests on 27th and 28th.
Okay. Yeah, the same
And
thing which I told yesterday, na? Yeah,
yes,
okay.
yes. And 25th is a holiday. That's what she's been.
Okay. So you are having lectures till tomorrow, and then you have
Yes.
3 days holidays. Sunday, Monday, Tuesday.
Yes, sir. Yes, sir.
Okay. Fine. So for Wednesday, okay, tomorrow is the last session then. So then Wednesday maybe like tomorrow I'll tell you. It's like Wednesday morning, maybe 9:30 we can have our the test, which is very simple one. Okay.
Yes, sir.
Yeah. Anything you want to say?
No, sir.
Okay. So for that also, you'll be getting a link like this only. So by joining on the link now, what you'll have to do is when you join the link when you are in the meeting, then you'll have to just go to assignments. So under assignments, now the test will be given as a quiz, as an MCQ. Okay. Once you see the assignments, under assignment, you'll be able to see uh, the the test will be mentioned as a quiz. Okay, and when the time is there, like say 9:30, at that particular time, it will be the respective faculty will assign the quiz, and then you'll be able to see the questions and answer them, the MCQs. Okay, so that is how it will be like. Okay, like say for my case. Okay, everyone clear?
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
Yeah, I was just mentioning where you'll be able to locate that. Under assignments, now you'll be able to see that as a quiz. Okay, and then it will be very simple. Okay.
Okay, sir.
Okay. Fine.
Thank you, sir.
So